Hello, and welcome back to the chapter 4 of Prep Math. And today we're going to revise inequalities. I hope you got ready and let's get started. So, in this chapter, we will look in more details at different types of inequalities such as linear, quadratic, as well as equations with absolute values and fractions. So, we will start with linear inequalities. Before going to the inequalities, we will look to inequality signs. So inequalities appear in practice so that you have an idea why we need them, when we need to limit the values that are not allowed to be exceeded or undershot. So for example, pollution level. So for example, pollution level could be on some, arbitrary number 20 or something, and then you can't go down. Or for example, you work in a lab and the temperature in this lab cannot exceed 20 degrees. And this could be also required for costs, data transfer rates, and to many other examples. So inequalities contain the following symbols, which are, so I will put them here. So they're less than, greater than, less than or equal to, and greater than equal to. And if you remember, the pointed end always shows the smaller number. Okay, in order to find solution set for inequality, let's have a look at some rules that they follow. Important thing to mention is that rules that apply for the sign, which are less than and greater than, they also apply for less than equal to and greater than equal to. We will start with the first rule, which is if both sides of an equality are swapped, the sign needs to be also swapped. I think it's quite clear because if we look at the example that 3 is smaller than 7, if we decided to swap sides, it's clear that 7 is greater than 3. So if we want to swap the sides to put A on the other side or B on the other side, if you remember in equation, we don't do anything, but in inequality, we change the sign. The next rule, if we add number to the both sides of inequality, then the sign remains the same. So any number, it could be positive or negative number. If this number is added to the both of sides, then so if any number positive or negative is added to the both sides of an inequality, the inequality sign remains unchanged. I can also show the small example for this rule. So let's say 2 is greater or equal to x, and then if we swap the sides, we move x here, we have to change the sign to the opposite direction. Then it will be x less or equal to 2. So, for the second rule, let's solve the following inequality. X plus 3 greater than 5. So we can do very close to the things that we did with equations. For example, we can subtract 3 from both sides. And according to our rule, our sign will stay the same. It doesn't change. So we just do it step by step. It means x plus 3 minus 3 greater than 5 minus 3. So again, sign doesn't change. Then we just leave the sign here. Then we have here x larger than 2. So, okay, let's move to the next rule. Next rule is dividing both sides or multiplying both sides of inequality with the same number, which is c. And c in this case is positive number. It's greater than 0. In this case, our sign will not change. It also remains the same. If number is positive, then we divide or we multiply with this positive number. The sign of inequality doesn't change. It's the same. Let's have an example here. Let's take the quadratic inequality. So 2x squared smaller than 4x minus 6. So here we want to do what we want to do, we want to divide both sides of an equality by 2. And according to our rule, our sign doesn't change. It remains the same. So here we will have x squared, here we will have 2x, and here we'll have minus 3. Okay, that's clear, I hope. Let's move on to the next property. Here we have very interesting case. If the number that we are dividing is negative, then we swap the sign. Doesn't matter, we multiply, we divide. So if it was less than, then it becomes greater than, and vice versa. So for example, minus 7x smaller or equal to 14. Here, to find the solution set for x, we want to divide our inequality to minus 7, both sides. If we do so, then we flip the inequality sign to the other direction. So if it was less than or equal to, then it becomes greater than or equal to. And then we will have x greater than or equal to minus 2. In the last part, if we raise both sides of an equality to a positive power, then the sign remains the same. It doesn't change. So, for example, we have x greater than or equal to 9. Then if we decide to square both sides, the sign will remain the same. This is also true if we have power in fraction form. For example, if you remember the square root of x, we can rewrite it also as x to the power of half. Since half is also bigger than 0, we can also apply this rule for this power as well. So in this case, x, I will just remove this so that you're not confused. So we had an inequality x greater than or equal to 9. If we will take square root of both these parts, square root here and here, so the sign will not change. So these are the rules. These rules will be applied to simplify or to find solution sets of inequalities. Then we start directly with linear inequalities. So what are the linear inequalities? Linear inequalities are inequalities in this general form where x is our unknown variable and a, b, c, d are real numbers. The solution set of an inequality is a set of all real numbers that we can just put instead of x, and this inequality will be true for them. So the solution set of an inequality is the set of all x numbers which will fulfill this inequality. All right. In order to find the solution set of an inequality, it's very useful to collect all the unknowns on one side and all the constants on the opposite side to find the solution set. So for example, if we have inequality in the form of 3x minus 1 less than or equal to x plus 2. Yeah, 2x plus 2. So this is our inequality. So as I said again, it's more useful to move terms to one side and all the constants to the other side. And this will give us x less than or equal to 3. This will be our solution set. If you didn't understand, I can draw the line. So we have a number 3 here and this is a number line. It means that x is smaller than 3. It means that all the numbers, including, because we have a closed interval, because we have this equal sign, including 3 are in our solution set. So any number in this limit from minus infinity up to 3, any number will fulfill our inequality. So this is a solution set of this inequality. All right, let's have a look to a different example. 2x plus 5 less than or equal to 2x minus 3. So for this inequality, we want to subtract 2x from both sides. So if we do so, 2x will just cancel. And then we will end up 5 being smaller or equal to minus 3, which doesn't make any sense. So it means that this inequality doesn't have a real solution. So then the solution set for this inequality will be empty set. So we don't have any real numbers that will fulfill this inequality. And let's have a look to the similar equation, but this time with different sign. So this time it will be 2x plus 5 greater than 2x minus 3. Again, if we subtract 2x from both sides, we will end up having 5 larger than minus 3, which is true, right? And then our solution set will be all real numbers. So you can also check it. If we take any real number here, it will be true. Let's take 1. If we take 1, then it will be 2 plus 5 is 7, and it's definitely greater than minus 1, right? So then you can just check and put any number here, and it will fulfill this inequality. It means like our solution set is all real numbers. Solution set of inequalities can be also visualized graphically. But before going there, let's have a look at graphical representation of different terms. The easiest one is the linear. Linear is just a normal form of ax plus b, where a and b are real numbers. And why it's called linear? Just because it makes a line. So if we take a simple term like, for example, x plus 1, very simple linear term. And we can take arbitrary values of x, points like -2, -1, 0, 1, and etc. And then find the equivalent for y-axis. And so here we have x, here we have y, and we can just get a bunch of coordinates for the points. And if we build all the points, we end up having this line, which is x plus 1. The linear is always a line, and it could be like this or like this. It could be just any line depending on two coefficients. We will get it to later when we will look at different functions, but now just have an idea. The linear term is always a line. The line represents the solution set of this term. Okay, next one is quadratic. If we take this term, which is x squared minus 2x minus 1, we can just take the bunch of values for x and just put them here and find y. If we plot them, we will end up having this interesting shaped curve, which is called parabola. So parabola, depending on what kind of quadratic term you have, can have this shape, can have this shape, just also depends on the other coefficients. The parabola is representing the solution set for this quadratic term. Next, we can have a look at the graphical representation of absolute value. If you remember, we had a look at absolute value, for example, of term x minus 1. In order to visualize this, we need to build two cases. We draw two lines, x minus 1 and minus x minus 1, which is also minus x plus 1. So we just draw these two lines in two-dimensional coordinate system, and solution set for our absolute value will be this blue V shape. And very close approach goes to the inequalities. And solution set for inequalities will look like following. For example, we have this term here. 2x plus 1 greater than minus x plus 4. So we have this inequality. So in order to visualize it, we have to draw these two lines, same on this two coordinate system, and we will get this two lines where we have 2x plus 1 here and minus x plus 4 here. I can also write it here. X minus 1 is here, this line, and this line is minus x plus 1. So we have these two lines. If we look at this inequality above, so we're interested in all x's which lie above intersection with minus x plus 4. Or in other words, this is our solution set for inequality. If we have just this sign greater than, then the intersection point will be empty and it's not included. But if we will have this sign here, greater or equal to, then the intersection point for this one will be included in the solution set. But here, since we don't have it, it's not included. Like the first x after this intersection point will lie in our solution set. So this is our solution set. I hope everything is clear here and we can move further.